Oh my giddy aunt. Rises and goings. Oh my giddy aunt. They can fuddle the mind. So allow me to attempt to unconfuddle yours. I'll try anyway. Well, you see, we have this wall which supports the first floor, which happens to have a toilet on it. Yes, okay. But you see, there is a thing called the rise. Yes, and there's a difference between the floor and the floor. That is your rise. But also, there's another thing, and it's called the going. The total going is the distance travelled. So the time when you enter your staircase to the point of where you actually leave it. Now, not at the angle though. No, across the floor. That is the going. So think of it like a triangle. You have your going across the bottom, and you have your rise going up across, up against the wall. That's the rise, okay? But we also got the individual rise, individual going. And the rise, the individual rise, is the distance between each individual tread vertically. But the going is the individual going, that is the distance travelled on each individual tread. Oh, are you confused? Well, I'll try and unconfuse you as well as unconfuddling you. I'll try, yes. Now, you see, to work this all out is actually really easy. A calculator really helps. Let's use some sort of maths genius. Now, for me, my rise happens to be 2,100 millimetres, so 210 centimetres rise, distance from floor to floor. The going, which is the distance travelled, and this is the distance or the space that I have got to fit the staircase in. And in this case, it's not necessarily to code because it's the only room I've got, and it makes the treads a little bit shallow, and the rises could end up being a little bit tall. Well, in this case, I ain't got a choice. This is the only option we've got to fit this in, other than knock the walls out. And I'm not about to do that. Not for a mezzanine, because that's what this actually is, a little mezzanine up here. Now, to work it out, you have to do a little bit of estimation, or you start basically working out what your rise is. So you get your rise measurement in your calculator, and you go, in this case it's 2,100 millimetres, and I think to myself, oh, could I do that in 7 treads or 7 rises? So I'll divide that by 7. All right, divide by 7, and that will give me a 300 millimetre rise. Now that's one hell of a rise. Yeah, you don't want that kind of rise on your stairs. No. So each one of those treads, you'd have to step up 300 millimetres, which is about 12 inches. Yeah, you need whopping great legs to do that. But it does mean, though, if you got 300 millimetres on the rise and your distance travelled only 175, it's 300 millimetres on a 7 rises. I can get away with 6 treads then. So 1750 divide by 6, I can have a 300 millimetre going, 291 millimetre going, which is a great big going, but the rise is huge. You don't want that, no. So I actually went with 11 rise. Okay, now when we say 11 rise, in this case it's 11 steps. You're going to be going up. 11 times you're going to be lifting the body onto the tread, including the last one. But that last one, if you look there, is basically actually the wall itself. Yeah? So with that, we don't actually put a tread there. We put what we call a bull nose or trimmer at the top of the actual stair. Now, if you haven't got no space for that to just drop into the wall a little bit, I have, you will need to include that extra measurement of 60 millimetres as a part of your going, or knock it off your going, and then work your going out for your treads less that last tread, because it's not the same as all the others. It's just easier that way. It might not sound it, but it is. You just reduce your going, say there's 50 mil bull nose at the top there, well then you take 50 mil off the bottom going, the total going, and that makes that 170. So 170 centimetres. So now I know that is 11 rises. It's effectively going to be 10 rises. So even though it's 10 including that last one, which we don't ignore, it's actually 10 risers. So it means it will be 10 treads. So all I need to do now is divide the going, which is 1,750, if I'm not allowing for the bull nose, and I need to divide that by 10. Well, it's obvious I knocked naught off. Well, it's simple in this case. Yours might be different. You might have 12 risers on a 13 tread staircase, which is a bit more normal. So you've got 175 for each individual rise. Now that is the actual amount of tread exposed. It don't necessarily mean to say that is where, or that is how wide the treads are. No. So if I grab a couple of treads here, here's 2 treads I prepared earlier. Okay. Well, the thing is, you'll have 1 tread. Okay, and these are 200 millimeters. So I've allowed a 25 millimeters overhang. So effectively the next tread will overhang by 25 millimeters, but the exposed tread is 175 millimeters. That is how much you've really got to actually step on, to tread onto. Now that includes also the overhang to the next tread, to the next tread, next tread, but the amount exposed, the amount of tread that's that is actually visually exposed if you look directly from the top is 175 millimeters. Now, the thing is, now what you need to do, once you've got your string all machined up, ready to go, you've worked out how long that's got to be, it's quite easy to do. You do it for Pythagoras' theorem to work out your C on your on your triangle, because this is a theoretical triangle that we have got here. Now, what I have done, okay, I've used my bench. So you could use another piece of wood if you like, but I've used my bench, and that represents the floor for which we're leaving the actual, leave the floor to get onto the staircase. The bottom, the ground floor. So that is the ground floor. We then have this piece of wood here, which I'll show you in a moment, which represents the wall. So that's one part of the triangle. So there. That's the other part, one part of the triangle. And that was the floor, which is the bottom of the bench. But then we have the string, which is where the treads are going to fall upon. So what I'll do is I'll just bring you a bit more of a bird's eye view to show you what I've been doing. So what we've got here is that long string, and we have this piece of wood here, which represents the wall, and the bottom edge of the bench, which represents the actual floor. Now, the thing is, when you actually put your marks onto your string, you must do it every rise individually. In other words, from the bottom edge here. So it's very easy to do. All you have to do is times the measurement of the individual rise, which is 1909 in this case, because it's 2,100 divided by 11, which is 1909. I only know that because I've done it about a million times already. So anyway, so that is the distance between each individual tread. So say for instance on the second tread, you times it by 2, third rise, you times it by 3, fourth rise, you times it by 4, and that's the measurement you use, measuring from the bottom edge. Do not be tempted to measure, mark one tread, then measure from that tread to the next, to the next, to the next, to the next. You will be miles out by the time you get to the top, which is from the floor. You might be, 20 millimetre higher or 20 millimetre lower even. It doesn't take much to be that far out when you've got 11 risers. So we always measure from one datum point. In this case, what we are saying is the floor. All right. So we grab our tape. All right. Bring it down a bit lower. And I literally, say for instance this one here, I'd grab my measurement, work it out on the calculator. I know it's 1909 times 2 for the second actual tread on the second rise. So I know it'd be 3818 millimeters. It's really 382 millimeters, near enough. For that mark there. I'll then work out my angle, and to do that I'll use a bevel. Now basically I've worked out exactly where I want this string to be by putting a mark on my bench at this point here that tells me where the actual end of the string is going to be. Okay, and also up the top there I've marked the top of the actual on the piece of wood here, there's a mark just there that represents the floor. So effectively, I've created a triangle, which is basically, I've mocked up a triangle, which is effectively the staircase in its space. Now, all I've got to do now is, now that's in the right position, I have to think to myself, okay, then I'll use my bevel, or you can use a couple of pieces of wood glued together, or screwed together, whatever, to create the same thing. I get my angle that way, and then I can go to the mark I've just created, then draw a pencil line across, and then literally just do the same. So that was the second, I'll do on the third, so it's 1909 times 3, and I'll do exactly the same thing again, which is 5727, make my mark, grab the my bevel, put my mark, my line across, and I'll do that, replicate that on every single one. Not working from each individual thread, but working as though I'm timesing it by the rise number that it is, or the thread that it actually is, to get a bigger number, and that way it will be accurate. So you won't have an error when you get to the top of your staircase. Now I've got to the stage now with this particular staircase where I can transfer the marks that I've put onto this string, and as you say, all I've done is put those lines across the string right to the end, and they represent all the actual threads. And all I've got to do now is think of it being in reverse. So the opposite string, which is sitting there, I'll mimic those lines, I'll marry those lines up, literally by sandwiching the two boards together back to back, then transferring the lines across, and then basically I have all these little lines there, and they'll represent the top edge of every single thread. So when I install the threads, okay, they will end up being flush with the top edge of the thread with those lines that we put on the string. Anyway, I hope that is it's clear as mud. Please leave it in the comments down below. But it isn't too difficult. But you could use one of these online calculators, but they won't always work out for you, because if your staircase isn't necessarily to code, they won't give you a measurement. They'll give you something near, or the nearest minimum. It might not work out for you, basically, is what I'm saying. So please click the like button and maybe subscribe to the channel, because then you get a warm fuzzy thing in your pocket every time I upload another video. So I'm going to say toodaloo, Toodaloo.